Hey folks, I guess we are live. Let me just check the stream quality. Could you also please confirm if everything, both the audio is clear and as far as the video is concerned that you're able to see my screen being shared. Can you please confirm that? Let me also confirm from my side that there are no hiccups. Yeah, I can hear myself fairly clearly. No major issues from my side at least. I can see also the screen, so cool. Okay, sounds good. Okay, so one thing that I wanted to mention, anyway, let's wait for a few minutes for everyone to join. But in a nutshell, I'll try to, so I went through the chat window from yesterday's discussion. I'll try to cover and answer some of the good questions from yesterday's live chat window using some examples little later. Also, some of the participants suggested some good functions to cover, which I'll be covering in today's session, right? So I just wanted to mention that. Okay, so everything is clear, good. So please understand that in a live session with so many students and so many participants, it's hard to answer everyone's questions in a live session, because unlike a class, if it's a physical class, people will raise their hand, ask question, all that would happen. Here it's very different, right? So it's so easy to put in a question, but it's so hard to answer because of time constraints. So what I've done today is I'll cover a few topics that I wanted to complete in object-oriented programming. Then I have picked up a few good questions from yesterday's live chat window, also a few suggestions from yesterday's live chat window, and I'll try to cover some of those things. And very importantly, a huge thank you to all the people who are answering in the chat window while I'm not able to answer. I see that for some questions, I see other participants giving very good answers. Thank you very much. I mean, you're helping everyone here. Thanks a lot. And yeah, so I'll try to cover some of these. Again, please understand that in a live session of this scale, it's very hard to answer every question that comes here, but we'll try our best. Sounds good. Okay, let me take a few general questions, then I'll go into C++, not C++, sorry. Then I'll go into Python object-oriented programming specifically, right? So, so somebody is asking, we are passing int variable and map function. In the map function, it just calls int. Why is it so? So the logic here is just look at the, again, whenever you have a doubt like this, so just type Python map function, right? So first read the documentation. Where is the documentation for this? Function reference, right? So, okay, Python reference. No, read the docs, sorry. I want to read this documentation. Again, I prefer reading the, you asked about map, right? I guess you asked about map if I'm not wrong. You asked about map function, right? So let's look at the map function itself. In the map function, the first thing that we pass is a function. Again, here we are not, again, if one very common misconception that people have, let me just open my writer. So again, the question that you asked was map, we just pass int here and some iterable object, right? Why are we not calling? So your question here is, why are we not doing this? Map, int, comma, and iterable. So the way it works is every function, so in the function place, all you need to give is the name of the function, right? The parameters to the function are taken from this iterable object itself. Each of the elements in this iterable object, imagine there is a list here, right? So imagine if I have this map int, imagine if I have a list 1, 2, 3. So list is an iterable object, right? So the way it works is the parameters of int. So it will call the int function, which is basically a typecasting function which casts everything into an integer. It will take each of these as parameters. Now your question here is, why do we not need the parenthesis here? Because that's how the function is defined internally. Again, this is something that you might appreciate if you know compiler design, or in this case the interpreter design. So internally Python stores every function. Okay, how does Python store internally functions? Python basically in your RAM, when Python loads a function, these are the lines of code that are part of a function. And there is something called as a symbol table. Okay, these are stuff that you learn when you go into the internals of Python, right? In the symbol table, where all the variables, all the functions, all the objects, everything is stored actually. So the way Python stores this is that there is a function called int and some other information about this function, including the location where, if it wants to execute this function, where in memory. Again, this is your RAM. Again, this also, symbol table is also in the RAM, by the way, right? So what it says here, if I want to execute the int function, where do I go in the RAM to execute each of the lines of the code, right? Because this function code itself is loaded into the RAM as part of the loader, right? So the way the symbol table is storing is, symbol table just stores the name of the function without the parenthesis. That's why the designers of Python just said, just give me the function name, I'll make it work, because in my symbol table, I just have the function name. I don't care about the parameters or the parentheses. You don't require to give the parentheses because that's how it is defined. That's why it's always important to read the documentation carefully. Again, if you don't understand symbol table, all of that, that's okay, right? Of course, see, there are layers of understanding for any programming language, right? So what we're trying to do is maybe the first 2 layers of internals. But then if you really want to understand, if you really want to go in depth and understand the programming language, you will have to read the internal documentation, internal implementation specifics. You have to know quite a lot of computer science in terms of compiler design, etc. Right? So again, this is the simplest way. Again, you just don't have to give the whole function name. That's all. Okay, sounds good. So somebody says, can we discuss some interview questions around OOP asked in ML interviews? Again, I have not seen anybody asking, at least I don't recall myself. Maybe there are a few cases, but I don't recall cases where people would ask object-oriented programming specific questions in the context of ML interviews. Because in ML interviews, I mean, even in top product-based companies, I don't recall any specific object-oriented programming specific stuff. Of course, if you worked as a software engineer, if you worked as a software development engineer for a few years, and then you're transitioning to machine learning roles, right? Then, and if the machine learning roles involves a lot of engineering or software engineering work, typically there is this round called as low-level design, right? So low-level design or object-oriented design round. This is the round in which a lot of, again, this is not asked to fresher software engineers also. This is typically asked to software development engineer 2 or 3, right? So these are people with at least a few years of experience in software development and who know the basics of object-oriented design and low-level design. So especially at companies like Amazon, Google, Facebook, all the top product-based companies, for software engineer 2 role or software engineer 3 role, right? 2 or 3, they would have a round called low-level design, where they would actually ask the object-oriented programming concepts and object-oriented design specific stuff like design principles, etc., or design patterns and things like that. For machine learning roles, you typically have 1 or 2 rounds of programming interview, and then you would have mostly rest of the 4 or 5 rounds as mostly machine learning specific rounds. You could have 1 round on data analysis, 1 round on probability statistics, 1 round on machine learning depth, practical applications, etc., etc. Even this programming round will revolve a lot on mathematical aspects of programming, a lot. And if you come from CS background, there might be some data structures and algorithms also. Very seldom, at least I don't recall any case where specifically object-oriented programming stuff was asked to machine learning engineers or machine learning scientists or data scientists, unless they worked as software engineers in the prior role where they were doing software design. Right? So if your prior experience involves object-oriented design, then they would say, okay, let's test where he stands on low-level design. Right? Sounds good. Oh, anyway, it's already 6:06. So let's get started. Let me just clarify a couple of things. So today the way we are going to run is slightly different from the previous days. I'm going to cover a bunch of concepts that are still left in object-oriented programming. I went through yesterday's live chat window. A couple of things. Some of you mentioned that the instructor is not answering all the questions. It's not possible, right? In a live chat like this, it's almost impossible to answer every question. So we try our best to answer a few questions. So it's first and foremost, it's important to recognize that it's not possible to answer every question, because if you start answering these questions, we will not be able to cover what we wanted to cover, right? Number one. And that's why we have some general Q&A sessions that we conduct. So we have general Q&A sessions that we conduct every now and then, where the objective is just only to answer questions that come in the live chat window. Even in that, we are often It's often impossible to cover every question, but we try. So in the general Q&A sessions, probably we can cover more questions from the live chat window than in an information session like this. Number one. Number two is so very importantly, there are a few volunteers. I don't know what to call them, and a very few good netizens who are answering others' questions. Thanks a lot. Thank you very much. I can't thank you enough, because whatever I could not answer, some of these volunteers, I mean, these are just other viewers like you. They're not somebody that we selected and all that. No, these are just other viewers who are answering good questions. Thanks a lot. You're doing a great job. Thank you very much. The third thing that I thought of was, I went through the live chat window yesterday. I took some of the key and very good questions and also good ideas that others have suggested. Like one of our viewers suggested, I forgot the name, that why don't we use the dir function? A very useful idea. So what I'm doing now is, once I finish these concepts, I'll cover a few key questions that I saw in yesterday's live chat window. Again, for each of these questions, I've written a snippet of code and I'll try to explain with a snippet of code. And I'll also teach you how to answer the questions yourself by just writing a snippet of code. I'll also cover a few good ideas that others have suggested in the chat window yesterday. This is how we'll go, okay? First, let's finish some of the concepts that I wanted to cover. Then I'll cover all the questions. If time permits, we'll cover more questions, right? Cool. Again, we covered a big chunk yesterday. That's why I couldn't answer many questions yesterday. Okay, so one of the very popular questions that I've seen repeatedly being asked, I thought I'll cover that first, is how is object-oriented programming typically used in an ML role in the industry? Typically, again, I'm saying typically because every ML role is different, right? There are some ML roles where you do more of research work. There are some ML roles where you do more of engineering work. So it depends on the role itself, right? But most often, you use existing classes. I showed you the example yesterday from matplotlib, right? So whether you use a matplotlib, whether you use scikit-learn, whether you use TensorFlow, you use a bunch of very specialized libraries that are meant for plotting, statistics, numerical operations, machine learning, deep learning. You mostly use existing classes. So you have to know what is a class, what is an object, basic understanding, right? Cool. Second thing that you often do, at least this is what I have done in over a decade of experience in a wide spectrum of roles. So reading documentation to understand how to use the functions, classes, and modules, right? This is something that you do. See, again, the functions, modules, classes, they evolve. For example, there is this module called Seaborn that did not exist just a few years ago when I was working and writing production quality code or even research quality code, right? So whenever new modules like this come, it is our job to read the documentation and understand the functions, the classes, and the whole module so that we can use it tomorrow, right? And nothing beats that. To read the documentation, you need basic understanding of object-oriented programming. Cool. The third one is to fix bugs and to understand error messages, right? So suppose you're using something from TensorFlow. Okay, you get an error message, some error message. You have to know what is an attribute, you have to know what is a method, you have to know those basic stuff, right? So it is extremely useful in fixing code bugs and understanding error messages. This is what I have done, extending existing classes to modify some functionality in an existing class. Okay, I've shown you this example yesterday, right? Yesterday I showed you about my URL shortener, right? My URL shortener. And this was, my URL shortener was the subclass, or it was the derived class from short URL final. I've shown you, imagine if this was there in some library or module, how can I modify it to the needs that I want? Again, what we'll do in the future sessions is we will see how to extend existing classes in machine learning libraries. For example, we'll take, let's say, logistic regression. Okay, I mean, I'm just giving an example, right? So logistic regression is a very popular machine learning model that is implemented in scikit-learn. So, right, so we will create a child class, or we'll derive a class from logistic regression, modify some functionality of logistic regression, right? And this is something that is often done because you want to modify. Maybe you want to modify a specific implementation of a function, or you think this implementation is not good, you want to change some implementation specifics. That happens a lot, right? Next, You also work a lot with software engineers to build ML classes. So for example, imagine you're building a huge product or a service. This is a huge product that you're building. The software engineers, the software architects, they write a lot of code. This is all the code that they've written. But they need somebody to implement a machine learning class, right? Or let's assume this is the machine learning functionality that you need to write. So they might ask a machine learning engineer or a data scientist or a machine learning scientist saying, hey, can you please implement this class with these functions, and these functions should be doing this, and we will call these functions from our code. Again, a lot of production quality code is written by software engineers. So your job is to implement a class with some specific functionality that they ask you, right? So here again, remember, you're not doing object-oriented design. You're working with experienced software engineers in writing the machine learning module, because the software engineers may not know how the machine learning internals work. Right? So you work extensively with software engineers to build machine learning classes for them to use in a larger software. Again, very importantly, a lot of people do this mistake. Please do not perform object-oriented design. This is what I meant when I said low-level design. I mentioned this earlier, right? So low-level design is typically an interview round that is conducted for software development engineer 2 or 3 at Amazon and other similar companies. It is again not a round that is meant for freshers, right? So even 4 are also called as principal engineers, right? So most of these guys have a low-level design interview round where they mostly do object-oriented design using something called as design principles. Again, this is typically done by senior engineers or architects in a role. If you do not know object-oriented design, please don't do it, because if you do not design it properly, it's a mess. Those of you who want to learn design patterns and who want to learn how to design, there is a very nice book from O'Reilly, which I've linked here. Again, this is a completely tangential topic. This is not a topic in machine learning. This is a topic in software design. Again, this is one of the simplest and a really good book that I love. Again, there are many other more complex books, but I'm linking you to a beginner's book. So if you want to learn how to do object-oriented design using design patterns, this I think is one of the best books for a beginner level. There are more advanced books, etc. But this is a very good, with lots of real examples. I really love this book. It's a great beginner book that I've recommended earlier also. Cool. So I hope this makes it clear. Again, as somebody was asking, in most machine learning roles, you're typically not asked in interviews object-oriented programming as much, unless you worked as a software development engineer for a few years or a software architect for a few years, and you know a lot of implementation specifics, right? Again, if you've worked as a software development engineer for 5+ years, people expect you to know some basics of object-oriented design. So in such a case, they might say, okay, since he has worked for so long, can we also test him on low-level design or LLD or object-oriented design, right? But if you have not worked as a software development engineer for at least 5 years, I don't think people will ask you object-oriented design or object-oriented principles for a machine learning role. Again, in the machine learning role, this is the lowest priority in terms of interview. Okay, just wanted to make that clear. Again, I have interviewed people with 5, even 10, 15 years of experience for machine learning roles. And in none of these interview roles, I recall a case where somebody was asked object-oriented programming specific stuff. I don't recall personally. Cool, sounds good. So let's get into multiple inheritance now. Okay, so what is multiple inheritance? Okay, so we talked about inheritance yesterday, right? So imagine if I have a class A, right? I inherited into class B. How do I do it? I just say class B, and within the parentheses, if I say A, this becomes my inherited or my derived class. This becomes my base class. We have seen this. Now, interestingly, there is also a concept called as multiple inheritance. Again, this is there in most object-oriented programming languages like C++, and of course it's implemented differently in different programming languages, but this concept exists, right? So the idea here is this. So the syntax is this: class, the derived class name, and I can derive it from multiple parent classes. So the way it will work is this: imagine if I have, let's say I have class A, I have class B, and I have class C. Now I can create class D, and I can derive it from class A, class B, and class C. So all the members, all the attributes and methods that are there in A are inherited by D. Similarly, everything that is in B is also inherited. everything in C is also inherited. But a quick question is, what if? I mean, this is an obvious question, right? Suppose imagine there is a function f here, there is also a function f here, same function name, right? Or same method name, or same variable name. Which of these is now actually inherited into D? Because it has the same function name. What happens in such cases? Those are the interesting cases in multiple inheritance. Again, multiple inheritance, while it's a beautiful concept in object-oriented design, this is much less used than simple inheritance in practice, even in object-oriented design. Okay, cool. Because there are lots of complexities that you can get into multiple inheritance. I'll show you one such complexity. Okay, again, this is a simple toy example. I've taken the code from OverIQ and modified it slightly. Okay, so look at this. Okay, let's write the structure here. Okay, so I have a class A which has this function called explore, right? So I have class A which has the function called explore. Let's write this down. I have class B. Again, class B is not inheriting from anything. So I have class B, which means class B inherits from object. Let's not forget that, right? It has search and explore. It has two functions, search and explore. It has two functions or two methods, right? So you have C. C has something called as discover. Again, remember, all these three, we should not forget that all these three are actually inheriting from object, right? Because the default class from which everything inherits is object in Python. Let's not forget that, right? So now next thing, look at my syntax of class D. So class D, A, B, C, right? So class D inherits from A. The order here is very important. It first inherits from A, then from B, then from C. The order is very, very important, okay? So it inherits first this, second this, third this. Now comes a very interesting question. So what happens now? Okay, so here comes a very interesting question. Okay, let me show you the output also. Okay, it's very simple actually. It's very simple to understand. Again, multiple inheritance can be extremely complex in other programming languages. Python tried to make it fairly simple and straightforward. Okay, so let me get a different color, a slightly brighter color. Just give me a second if I can get. Okay, this color is also cool. This is green, right? Yeah, this is cool. So I create an object. So D object is basically an object of type D, right? So when I say, so remember, D is an object of type class D. Now when I call D or D object, okay, sorry, I should just call it D obj. Okay, when I call explore, remember there is an explore in A, there is an explore in B. Which explore should it call? Okay, so the Python implementation, the Python documentation or the programming language implementer said, whatever is there first in this order, that will get a preference. So this explore will execute here. For example, in this case, so again, explore is there in both the cases. So when I say explore, because the order, I told you just a while ago, right, that the order is important. Because A is before B, A's explore will be inherited by D, not B's explore. So for example, in A's explore, if you notice, what is the code that we have? So def explore, I'm creating a method where I'm saying explore in A called, I'm just printing this. So the moment I call D object.explore, what it prints is this, explore in A called. That's how it should behave, right? So this basically returns this. So remember, the order here is very important. Okay, left to right, that's the important portion here. Okay, again, you can see this in the documentation also. For example, if you go to, I showed you the doc earlier, right? Python classes documentation. Okay, in this tutorial also, they have this, okay, multiple inheritance. Look at this. It clearly says in this document also. Okay, you can, okay, so, okay, so, oh, there is also another case. There is depth first and left to right. Right, so the meaning between, so it always, so if I'm given these three, it goes from left to right. Now what does this depth first mean here? Imagine a scenario like this. Imagine I have A, B, C and I have D. D is derived from A, B, C, right? Now A, let's assume, is derived from X. Let's just say, right? Suppose now there is a function F. Imagine there is a function F here, there is a function F here, there is a function F here. There is no function F here. So when now if I say D equals to this object and if I say D dot F, if I call D dot F, which F will get executed? Look at this, the order is important. It always goes depth first. So D goes to A. It says, do you have F? No, I don't have def, but I don't have F, but F is there in my parent. So first it goes depth first. It goes depth first, right? So since this F is there, this will basically be equivalent to executing the F in X, the F in class X. So depth first. Okay, you're going depth. So first this, again, depth first and left to right. That's also important. Left to right. You always go to the leftmost first. Then if it has another base class, you go search for that first. Right? So since F is here, left to right, depth first is the logic here. Again, these types of multiple inheritances are something that good object-oriented design should avoid. Like very, very complex cases they should avoid, because it will make maintaining code very hard in the real world. But sometimes it's necessary. Okay, so where were we? Okay, we were here, right? So next, now if I execute D object search, again, where is search? Search is only here. So B, search in B is called. So this will execute. Now if it calls discover, okay, what happens if I call discover? Discover is there only here. So discover will call. Now within D there is another function or method called test. So if I call test, what happens? D itself has another function called or method called test. So if I call dObject.test, it will first check here. So first it will always check. So the idea which is very important here is this. First it will check in the class that I am part of. Then so left to right and depth first. Depth first. Okay, first it will check in the same class. First it will check if it's in the same class. If it's in the same class, cool, no problem. If it is not in the same class, it first goes to the left in the order in which you have inherited. Look at this, it goes to left. And if A has other parent classes, it keeps going there. It keeps going depth first. If it is not there, then it goes to the next one, and so on and so forth. Right? So that's how multiple inheritance works. Again, multiple inheritance from a software engineering perspective, from a software design perspective, can be crazy to maintain. Again, multiple inheritance is extremely dangerous. That Java actually comes up with some interesting concepts, because C++ had straightforward multiple inheritance. And when people wrote large software in C++, multiple inheritance would create so much of havoc. So Java introduced a concept called interfaces and things like that to get away with some of the headaches of C++ multiple inheritance. Python is like, okay, we have a lot of, again, Python makes the language simple. Again, Python doesn't want to have all the complexity of Java or C++. So they said, okay, this is a very simple thing, we will have it, but from an object-oriented design standpoint, we recommend that you avoid it unless it is absolutely necessary, right? So that's why there are very few real-world examples of complex software where it is used. It is used, I'm not saying it's not used, but very few examples. Okay, so next there is this very deadly situation called as a deadly diamond. This is a standard problem that you encounter in multiple inheritance. Okay, again, it's a very standard problem. This is a problem that C++ designers like. It's called the diamond inheritance. It's also referred to as the deadly diamond problem in multiple inheritance, right? So look at this. I have class A. Okay, class A has explore. It has a method called explore. Then I have class B. Class B has something called as explore, right? Again, oh sorry, my bad. I should draw it carefully. So B is inheriting from A. Let's not forget that. So you have B here. B is inheriting from A. Okay. So B also has its own explore. Each of these explore functions just say explore in B, explore in A, explore in C. Right. So again, you have another class called C. C is also inheriting from A. So you have C. C also has explore. Now you create D. This is where things go crazy. Okay. Now you have D here. Okay. D has no other implementation. D is an empty class here. Again, this is one other application of empty classes where if you want to inherit from multiple classes, but you don't want to implement anything here. Okay, that's another example of an empty class which is used sometimes. Not very often, but sometimes. Now let's see what happens. Okay, so D is empty. So now what I've done here, I've created an object of type class D. Okay, let's call it D object. Okay, let me change the color. So I have D object here. Now when I say D object.explore, what will run first? Okay, remember, it always does left, first it checks in the same class. It checks in the same class. Then it also follows left to right and depth first. Right? So this makes life much more easy in Python. Okay. So it goes up. Again, my inheritance order is B followed by C. In the same class, I don't have it. Explore is not there. So B is what I have. So is explore there in B? Yes, it is there. So I'll go execute it first. Very simple. So when I say D object.explore, explore in B is called. Again, deadly diamond is a problem that can make your software design crazy, especially in C++, where there is a lot more complexity in object-oriented programming in C++ than what we are seeing in Python. Right? So deadly diamond is not a very crazy problem in Python specifically. Again, there can be some boundary cases where things are crazy, but this is how Python operates in a deadly diamond based or a diamond inheritance. Very simple. Again, you can modify this. What if there is no explore here? Okay, let's ask that question. What if there is no explore here? What should it do then? Right? So from what I think it should execute A, because left to right parent, right? So let's actually try that. Okay, I think it should execute that. So let me just comment this. Okay, so now, yeah, B does not have it. So what is our structure now? B does not have it. Now if I execute it, what will I get here? Okay, let me just execute this. Okay, so what we do? B does not have explore. D explore is what I'm calling. So it should actually print A explore. Expected indentation. Sorry, I should say pass. If there is nothing, I should say pass. My bad. Class B pass. Okay, now I think it should work. Oh, it's calling in C, but it should go. Okay, this is the problem. Okay, so it's calling in C. So one second, what is the order here that they say? Parent class as depth first, left to right, not searching twice in the same class where there is an overlap in the hierarchy. Okay, so there is also this case. I forgot. Yes, okay. My bad, I got it wrong. Yeah, so it executes C. So the way it's doing it is this. Look at this. It's doing depth first, left to right. Again, there is a third case, not searching twice in the same class when there is an overlap in hierarchy. So in our case, we have an overlap in hierarchy, right? So look at this. In our case, where is the diagram? We have an overlap in hierarchy because this and this, both of them have the same thing. There's an overlap in hierarchy, right? B's parent class and C's parent class are the same. Right? So there is an overlap in hierarchy. In the case there is an overlap in hierarchy like this, I forgot to read that point. Sorry. If there is an overlap in hierarchy, it just goes and executes this. Again, to be honest with you, I have never seen deadly diamond being implemented in production because people know that it's a tricky case. To be honest with you, I fell for it. Like I assumed that it should print A, but then I forgot to read this single line. Again, if you forget to read this single line in the documentation, it's very easy to make a mistake. So in general, multiple inheritance is filled with potholes if you're not careful. Deadly diamond more so, right? Just a simple example that I showed you where at least I fell for it, right? So again, it all depends on how clearly you read the documentation. Again, the biggest problem here is not everybody reads the documentation thoroughly. We all read the documentation to whatever depth we want to use it, right? So again, please don't use deadly diamond type inheritances unless you need it. And if you see it anytime when you're working with a software engineer, if you see it, just point it and say, do we really need it? Right? Not just in Python, in C++, Java, wherever you go, it's a tricky case. Okay, good. So this was a good lesson for me also, because I've forgotten how this works. Again, to be honest with you, I'm not perfect. I forget all these things. I experiment, I figure it out. Right? So, but again, if I were a software engineer, I can't afford to do this. As a machine learning engineer, I can say, I missed this. That's okay. Right? But if I was designing large software, I have to be much more careful with these. Okay, sounds good. The next concept is called polymorphism. So, okay, let's go to polymorphism now. Again, it's a very standard technique in many programming languages. It's also very important in the context of object-oriented programming. But before we go into polymorphism, what does this word mean? Poly basically means many forms, right? See, polymorphism basically means many forms or different forms. For example, look at this. When I just, if I say 2 plus 3, okay, what does it return in Python? It returns 5, right? Look at this. My plus is an operator. to which I'm passing two integers here. If I do the same thing, same operator, look at this, it's the same operator, but completely different strings. Same operator, completely different strings. What happens? It still concatenates and returns me A, B, C, D, E, F. Now, which means the plus operator is behaving differently based on what I pass. In different contexts, the plus operator is taking different forms. Polymorphism basically means many forms. So the same plus operator is basically performing numerical addition here. The same plus operator is doing string concatenation here. This is what is often referred to as operator level polymorphism. It is the same operator but behaving differently based on the parameters that you have. Number one. Then there is something called as function level polymorphism. Okay, take a length function, the length function that we have in Python, right? I can pass different things to it. Look at this. I can pass a dictionary, I can pass a string, I can even pass a set here, right? Whatever I pass, it will print the length of or the number of elements that are there in that structure, in the data structure, right? String is also a data structure. This is basically a list. Whether I pass a list, whether I pass a string, I think I said dict, sorry. Whether I pass a list, whether I pass a string or a set, it will still print the same thing. So if you think about it, the length function also is performing function level polymorphism, which means it is behaving differently. It is printing, see, at the end of the day, it is printing the same thing, but even if I pass, whether I pass a list or a string or a set, it is still working it out, right? So that's called function level polymorphism. Most object-oriented programming languages have class level polymorphism, right? Let me just explain class level polymorphism. Cool. So let's go at class level polymorphism. So imagine if I have this class A, def p self. Okay, I'm just creating. Okay, let's just see it. Very simple code actually. Let me just scroll down a little. Okay, so that I can show you the output also. Okay, so I have class A, which has a function p, and it just returns function p in A. Then I have class B. They're just being inherited. They're just derived classes from object. Nothing fancy here. It also has p. Cool. Now look at what I'm doing here. This is the interesting part. So I create a variable A of type A, variable B of class capital B. Again, lowercase I'm using for variable names, uppercase I'm using for class names. Again, this has function P, this has function P. Now here comes the most interesting part. This line is the crux of, it's one of the great ideas of polymorphism in most programming languages. For example, imagine I take A and B, I create a tuple out of it. Right? We know tuple is iterable. We have seen this in the previous live sessions. We know tuple is iterable, which means I can first pick the first item, then the second item, so on and so forth. Suppose if I want to write a for loop like this, for I in AB. Again, what is this? This is basically, so let me explain this function, right? Let me explain this two lines of code. For I in A comma B tuple, print I dot P. Suppose I call this. How does this work? Right? So first what happens? First I will be equal to A. Look at this. First I will be equal to A, because this is basically iterables, right? Variable I will be equal to A. Then I will execute I dot P. What is I dot P? Is nothing but A dot P. Right? So what should execute? It's A's P method. This one should execute now. Right? Look at this. In the first iteration, I equals to A. Then I'm saying I dot P. Now what should this execute? This should execute this line. Logically, if you think about it. Next, in the second iteration, I will be equal to B. Now when I say I dot P, what should be executed? This should execute B's P function. Now what is happening if you think internally? Internally, if you think what's happening is this. Which function is being executed, whether this function is being executed or this function is being executed, depends on the object type, right? The function that runs or executes depends on the object type. So now, again, look at this. A is an object of type capital A, B is an object of type capital B, right? Now, your I look at this, what is happening in the first iteration, this is what is happening, in the second iteration, this is what is happening. If you think logically, in both cases, I dot P, it's the same thing that is running. But this will go and run A dot P, this will go and run B dot P, because it depends on the object type. When you say I equals to A is an object of type capital A. So A's P will be executed. So polymorphism or class level polymorphism, right, in Python basically says the function that gets executed depends on the object type, making the code much more easy to work with. For example, imagine if this did not happen. Imagine if this did not work like this. Imagine if we did not have polymorphism. Then if I were to write a complex loop like this, again here we have only 2 objects. Imagine if I have 100 objects of many different types, right? Suppose I have 10 classes and I have 100 objects from these 10 classes. I will not be able to write this for loop without, wherein I have objects of different class types without having class level polymorphism, right? That's an important catch for us. Cool. Now look at this. Now, okay, so we have printed this. So what happens here? This for loop, look at what is printed. First, function P in A is printed, then function P in B is printed. Okay, so this loop runs twice, and first function P in A, then function P in B. Cool. Then I've just put in a bunch of lines here, so as a separator. Now let's look at a slightly different concept. Okay, whatever we have done here in an iteration, let's see it in a simple expanded code snippet. If I say x equals to A, now remember A is an object of type capital A. Now when I say x dot P, what should execute? A's P should execute. A's P, class A's P function should execute. That's what it executes. Cool. Now the moment I say x equals to B now what happens? X is no more, again, when I say x equals to B, what happens? B is an object of type class B. So x is now an object of class B. Right? So when I say x dot P, what will execute? B dot P will execute. And that's what you see here. Again, what I've done here is the code that is there in the for loop, I've just expanded it here for clarity. Whether you do it like this or whether you do it like this, look at this. This line and this line are exactly the same. But you're getting 2 different outputs because x is pointing to an object of class A here, x is pointing to an object of class B, and based on the class of the object being pointed, the corresponding P function is executed. Right? Cool. Now polymorphism and inheritance can also be combined. Okay, let's go into it. Okay, let me finish this. We have iterators also, right? So, okay. So let's see, there are a few examples, then I'll go to the questions from the previous session. I just wanted to finish these in the next few minutes. Again, there are a few, again, if required, we'll extend the session by 20-25 minutes if need be. Okay. I hope we don't need it, but if we need, we'll do it. Okay, sounds cool. So, okay, polymorphism plus inheritance, right? So let's go into it. So I've taken, this is an example that we saw yesterday, right? We saw a class called shape, rectangle, if you recall. Look at this, we have seen this, right? We have a class called shape. We have seen this yesterday. We have a class called shape. From shape you get rectangle, right? From rectangle, from shape we also have circle. We have seen this example yesterday, right? So how does polymorphism work in the case of inheritance? In the previous example, there was no inheritance. So this example, we'll use both polymorphism plus inheritance in an example, because rectangle and circle are derived classes from shape, right? So let's see how this works. Okay, the same code snippet. I haven't changed much. It's the same code snippet. I just wanted to change this. This part changes, except that this code that we have seen yesterday, it's the same code that I'm using. Now here comes the most interesting part. Okay, so let's go into it. So I have S as shape. Okay, so I'm creating a variable S, lowercase s of class shape. I'm creating R of rectangle, C of circle. Now look at the code that I'm writing here. For I in SRC. Okay, look at this. So again, this is a loop where I will first take S, I will be equal to S, then I will be equal to R, then I will be equal to C. Now when I say I dot get color, what should it print? Okay, first it prints S dot color, again, the color function that is there in the shape, then the get color function which is there in the rectangle, because it all depends on the object type. But here is a very interesting case, right? So for example, okay, first case is simple. Okay, I have S here. I say, so I equals to S. Okay, let's write this down actually. That might be better. Okay, first iteration, I equals to S. So when I say I dot get color, what should get executed? When I say I dot get color, what should get executed? The get color function that is there in shape, and that's simple. Okay, so there is a get color function. Where is this? There is a get color function. The default value of color is always black. It will print that. Cool. So you get this print statement that you want, right? So you get this print state. Let me just erase this. This is okay. So you get the black. It prints black. So that's cool. Second iteration. Okay. In the second iteration, I will be equal to R. Now when I say I dot get color, what happens? So first thing that you have to notice here is the get color is not defined in rectangle. Look at this. In the rectangle, the get color is not defined. But rectangle inherits from shape, which means whatever is the get color that is there in the shape is inherited by rectangle. So what happens now? When I say I dot get color, what happens now? So it goes to a rectangle. Look at this. It goes to the rectangle class, sees if there is get color. There is no get color that I have implemented here. Then it goes to its parent. Its parent has a get color. So it will actually, this will basically execute the get color in shape. Because rectangle doesn't have it. Rectangle is inheriting that get color function from the shape. In the third case, I will be equal to circle. Same thing. Circle also doesn't have get color. So when I say I dot get color here, when I say I dot get color, what happens now? The circle also doesn't have get color implemented, but the get color is inherited from shape. So it will go ahead and execute the shape's get color, which means in all the three cases, the output will be black. Because the shape's color is by default black in our implementation, right? So if you look at this, the shape's default color is black, right? Because the default parameter in the constructor, color takes black, and you are saying self underscore underscore color equals to color, right? So very simple code. Again, this is how your polymorphism in the context of inheritance works. Now there is another catch here. Okay, so imagine if I just say again, this is one more example. Both rectangle and circle have implemented a function called get area. They have their own functions. They have their own functions of get area. Okay. So the shape does not have get area, right? This is derived from this. This is derived from this, right? So now what happens if I say I equals to R comma C, I dot get area. So I will first be equal to R. When I say get area, the rectangle's get area will be printed. Right, so look at this. I'm creating a rectangle with length 10, width 20. So the area is 200, which is printed here. Cool, very simple. Next, when I say in the next iteration, I will be equal to C dot get area. The circle's get area will be called. The circle has a radius of 2. So if I print the area, I'll get 12.5. Cool. So this is how polymorphism plus inheritance will work out. Okay, so let's go through some more examples. Okay, so this is a very nice example. So let's look at polymorphism and inheritance in the context of inbuilt data structures. Remember, all of your inbuilt data structures, even your int is actually a class in Python. We have shown this yesterday, right? So imagine if I have D, which is a dictionary. Again, D is nothing but it's an object of type dictionary. It's an object of class dictionary. L is an object of class list. S is an object of class set. Right? And again, we are initializing them because these are inbuilt data structures. You don't have to call dict, you don't have to follow the same notation that you do for other classes. There are some shortcuts because these are inbuilt data structures. Now comes the best part. When I say for I and D, L, S, again, all these three are inbuilt data structures. Behind each of these data structures, there is a class. So when I say I equals to D, L, S, remember that my dictionary, my list, and my set, all these three classes would inherit directly or indirectly from object, because object is directly or indirectly. Okay, it could be direct or indirect. I've not seen the code behind how dict, list, and set is implemented in Python. I've not seen it for this session. But anyway, everything has to be derived from object. And let's not forget that I discussed this yesterday, right? Object has this underscore underscore string. Right? Object has this function called underscore underscore string, which will help us print anything that we want to print. Now within dict, this is the interesting part. The people who implemented the dict data structure within Python have overwritten this string. I'm sure of it. They've overwritten the string. Again, they're inheriting it from object, they've overwritten it. Similarly, there is a string implemented in list. There is a str implemented in set also. Now, the implementation of str or string in dict says, okay, whatever are the elements in my dictionary, I want you to print like in this format, curly braces, right? My key 1, value 1, comma, key 2, value 2, so on and so forth, braces closed. So the underscore string underscore, let's call it the string function, right? The string function which is there in object would have been overwritten within dict, and this says if anybody wants to convert any object for printing purposes, this is how it should print. This is defined within the dict's internal implementation. I'm sure of it, 100%. Right? Similarly, within the lists implementation, there is this overridden stuff, and it says, okay, you should always print all the elements that we have in the list, start with this braces, print each of my values, value 1, value 2, so on and so forth, with commas and all of this. Set says, print all of them with the curly braces, the value 1, value 2, so on and so forth, curly braces. So what's happening now? Okay, this is how these things are internally implemented. Now, when this line is executed, what happens? First, I will be equal to D. Now, when I say print D now, so print I. See, look at this. In the first iteration, I equals to D. Right? Now, what are we doing? Print I. Print I basically means print the dictionary. Again, the way the print function is implemented, somebody asked this in yesterday's live session also. Somebody said, okay, how does the print know that it should call underscore str underscore in this? That's how the print function is implemented in Python. Right? The print function is implemented such that when you pass any object to it, if that object, if the class that this object belongs to, look at this. So, okay, let's take this example concretely, right? So, I equals to D. So, when I say print D, the way print is implemented is it says, okay, I is there. What is the data type of I? I is, or what is the class of I? I is an object of type dict. So, let's go and check in dict's implementation if underscore str is there. If it is there, let's call that whatever string it returns, I will print it. That's how the print is internally implemented. So when you actually execute this code, I is initially D. But what is happening here is, so this is calling dictionary's string function. In the second iteration, I equals to L. So when I say print, what is happening? It is calling lists underscore str function. In the third iteration, I equals to S, and S is an object of type set or a class set, right? So it is going to call sets string. That's why this whole thing looks so beautiful and works out of the box. But this is what is happening internally. There is polymorphism that is happening internally. There is inheritance from the object class, which ensures that the string is available in all these classes, and the implementers of dict, list, and set have overwritten it. Again, I wanted to show you a real example of polymorphism inheritance by using inbuilt data structures, because these are extremely simple classes that are already implemented in Python, right? Cool. Next is the concept of iterable objects. Oh, this is very interesting. Okay, so we all know what iterable is, right? We have discussed this in the previous live sessions. Let me do a quick recap. So when I do this, whenever I want to use something like this in a for loop, whenever I want to say for I in something, if I take a list here, list is iterable, which means what happens here? First I will be given the first value, then I will take the second value, then I will take the third value, then I will take the fourth value in each of the executions of this for loop. So these are called as iterable objects. Okay, your tuple is also iterable. We have seen this in the previous examples, right? So these are iterable objects. Cool, simple. Now can I create, okay, this is the interesting part. Can I create, again, remember that this is an object. Let's not forget that basics. This is an object of class list. It's an object of class list. So can I create classes? So the question here is this. Can I create classes whose objects are also iterable? So I want to create iterable object. I want to create a class. Look at this. I want to create a class where the objects are iterable like a list or like a tuple. Can I do that? Or like a string for that matter. String is also iterable, we know that, right? So can we do that? That's the question, right? So iterable objects is a very interesting concept. It's there even in the documentation in lots of detail. So if you go to this, again, this is not a documentation, this is just a tutorial. So iterators is a very interesting concept. So let me go through it, okay? Again, this is a very, very nice example. It's a beautiful example from Python official tutorials. I mean, it's a very real world example. Look at this, imagine, okay, let's talk about the real world problem, then we'll come to the solution. So when I write like this, look at this, this is my list. When I write, again, remember that list is an inbuilt class and which also implements the inbuilt data structure. Now, whenever I write code like this, it first takes the first value, then the second value, then the third value, and then the fourth value. Is it possible that instead of going in this order, if I give a list, suppose if I write this, if I write for I equals to, for I in 1, 2, 3, 4, if I say print I, right? So the way list is implemented for iterators is first it takes the first element, second element, third element, fourth element. But I want it to be in reverse order. I will write it like this. First it should take 4, then it should take 3, then it should take 2, then it should take 1. So I want to reverse the order in which my I will take values. The default is this, I first takes 1, then 2, then 3, then 4. But if I want to reverse it, how do I do it? Cool. So this is a very nice example from Python official tutorials. It's a beautiful example. So here comes the fun part. Again, I've just copied this code from Python official documentation. So the idea here is this, let's create a class called reverse. Okay, let's create a class called reverse. Okay, I'll explain this class called reverse and we'll see how we can make any object of this class iterable, any object. Okay, here comes the fun part. First, I'm creating my constructor. My constructor, look at this, I have self and data. This data can be anything. This data, again, I'm not saying the data has to be list or anything. Look at what I'm doing with the data. I'm first creating a variable within this class called data, self.data equals to data, self.index. So in my reverse class, I have data and I have index. These are the two attributes that I have. These are the attributes, right? So these are the attributes that I have. Of course, I have a constructor here. And if you want to make objects of a class iterable, you have to implement. Okay, this is very important. You have to implement both the iter and the next functions. Again, this is given in the documentation. So if you want to implement them, where is this? The function blah, 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 blah. Okay, for statements called iter blah, blah, blah. Okay, sounds good. So what you have to do here is you have to implement this function. What are you doing here? Again, this is just underscore underscore iter. There is one more very important function that you have to implement called next. The iter function, it just takes the object, returns the object. Very simple, nothing fancy here. Okay, but if you want to make objects of any class like reverse here, iterable, you have to, this is mandatory. You have to implement this and you have to implement this. Let's look at the implementation of next. Again, remember that this data can be anything. The data can be a list, it can be tuple, it can be a string. Okay, look at how it's done. It's done very beautifully. Okay, so now in that, so the iter function basically says, if you give me an object, I'll just return the same object. It's not doing anything fancy. The next is what is doing. Okay, I'll explain you how the next, let's understand the function, then I'll explain you how the whole thing works. In just be patient, 5 minutes, I'll explain this. Okay, the idea here is this. So it says, because look at this, I have two attributes here, right? Again, I have an init function. I have basically a constructor. I have basically this iteration function. I have the next function or method. These are the three methods that I have. Now let's see how this. Let's understand the implementation. What this is saying. This is saying, if the index value equals to 0, again. Suppose, let's just take this, right? Suppose in this data, suppose I pass 1, 2, 3, 4. Okay, let's understand this. Okay, so look at this. If I say r equals to reverse, I'm creating an object of type reverse class. And what am I passing here? 1, 2, 3, 4. So what is this? This is nothing but the data that you're passing, right? So in the data, what happens? You get 1, 2, 3, 4. Right? And what is the index being initialized to in the constructor? Index is nothing but length of data. What is the length of this? Length will be equal to 4 because there are 4 elements here. Till now everything is cool. Now comes the fun part. Okay, I'll explain you how the next works. Now when it says for I in R, look at this, for I in R, what is R? R is nothing but it's an object of type reverse. Internally, look at this, internally it is storing this dictionary, this list, right? This list of 1, 2, 3, 4 is being stored internally within this class reverse in an attribute called data. Okay, it's being stored internally. Now, okay, so let me just erase this part so that I can explain this. Just give me a second. I'll erase this part so that it's easier to just scroll up. Okay, so now look at this. So when I say for I equals to R, now what should happen here? This basically says that we want to iterate this, right? So this this underscore iter basically makes this object iterable to start with. So R is an object of class reverse, and every object of class reverse is iterable now because of the presence of this underscore iter, right? Because it is iterable, there is no error in this line, right? Because it is iterable, there is no error in this line. Next, look at this. When I in R, I don't want to rewrite the same line, but anyway, I'll explain this. So when I say print I, look at how this loop executes. This is where the next function plays an important role. So what will happen here? First for I in R, we don't know how R works internally, okay? Because there is this underscore iter, it makes any object of class reverse iterable. That we know. Next, what is the first value that I should take now? Look at this. This variable I has to take some value of the values that are stored in R. What value does it take? For that, you have to go to next. So whenever we run this line for I in R, whenever we want to, so this will run multiple times, right? This is basically an iteration, right? It will run multiple times. Whenever the value of I has to be initialized to some value based on the object R, as soon as we want to do this, I equals to what? To determine this, Python goes to the underscore next. So the underscore next function basically tells us in an iterator, give me the next value that I want. That's why it is called the next function. Now, how is the next function implemented? It says, if the index value equals to 0, then raise an exception. There is an error, that's why it will raise an exception. Otherwise, again, index value is not equals to 0, it is equal to 4 now. So it says, okay, there is no error now, so we don't have to raise an exception or an error. Self.index equals to self.index minus 1, which means this index value will become 3. Again, this is all object R's data. Every object has this data, right? This is all object R's, lowercase r's data. So index becomes 3. Then it says return self.data self-index. So what is self.data? Self.data is this. Index is 3. So what would it return? It would return data 3. What is data 3? It is value 4. So now this next function, see, whenever I has to be given a value, it will call the underscore next function. Now, why does it call the underscore next function? Because that's how Python language defined it. There are some rules of a language. So the Python language said, whenever we want to iterate, whenever I want to initialize this variable to one of these, to some value from an iterable object, I will call the next function. Whatever the next function returns, I'll place it here. The next function returned 4 here, right? It returned this value, right? Then it will say print 4. So what do you get? You get print 4 now. This is over. Now, as soon as I've printed, this is for loop, right? In the second iteration, again, I says, I want a value. So I goes to object R and says, give me a value. Now, Python rules say, okay, R is an iterable object. So we have to go and call the next function. Now, how does the next function work? Next function checks, is the index 0? No, the index is not 0. If it is 0, we'll raise an exception, or else decrement the index. The index becomes 2 now, right? And return the value in data 2. So it will return 3. Look at this. Look, I becomes 3. In the next iteration, I becomes 2. In the next iteration, I becomes 1. Cool, right? So you can make any object iterable by just defining this function. This function says that any object is iterable. Any object of class reverse is iterable. This function says whenever I have a line like this, and whenever I want to pick I equals to, give me a value. Whenever this line is executed, I in R, okay, I says, okay, give me a value. I goes to R and says, please give me a value from your whatever you're storing internally. I don't care how you're storing it. So then we go into R. Python internally does this for us. It goes into the next function. Whatever the next function returns, it will place it here. So the way we have written the logic for the next function is as if we are iterating backwards. We are not iterating forwards, we are iterating backwards. The beauty of this implementation is whether we pass a list here, if you pass a list, it will work. But we have not used anything specific to lists here, right? This could have been a string and it will work. This could have been a tuple and it will work, right? Because all the functions that we have used, the index, all the functions, all the methodologies that we have used, see, it will even work if I pass, instead of passing a dictionary, if I pass a tuple like this, it will simply work. Because for a tuple, again, remember, okay, even for string it will work. Okay, so let me show you multiple cases. Okay, good. Let me show you where it will work and where it will not work. So if my data that I pass into the constructor is a list, it will work. Because list is indexable. I just need the index, right? Here, again, what am I doing? Given the data, I'm indexing it and I'm getting the length of the data. These are the only two places where the data's functions, where I'm performing some operation on the data. Right? Here I'm indexing it. In this line, I'm indexing it. Sorry. In this line, I'm indexing it. In this line, I'm getting the length. So wherever the length function works and wherever I can index, I can use the data structure. Right? On a list, I can do it, so it will work. Right? On a tuple, I can index. Right? I can also get the length, so it will work. On a string, it will work. Look at this. If you want to reverse a string, this is the object-oriented way with iterators to do it. Right? But it will not work on sets. Why doesn't it work on sets? Okay, simple. Look at this. It doesn't work on sets because where does it run into an error? It will run into an error in this line because length on a set is okay. You can say length and you can give a set, right? You can give a set and it will work. The length function will work, but a set is not indexable. And it says this, set object is not subscriptable, which means you can't index into it. So that's why it will not work. Cool. Again, here, what are we doing here? We are creating a class whose objects are iterable, right? And this class, I can pass in the constructor, I can either pass a list, I can pass a tuple, I can pass a string, anything that is indexable and anything on which I can call the length function. That's the idea here. Okay, sounds good. So now let's go into a few questions from yesterday's live session. Okay, sounds good. Okay, are there any questions here which are important? There is slight buffering. I don't see any hiccup from my side because let me just check. Oh, there is some buffering. 1 second. I think there is some buffering from my side. Oh, there is some buffering from my side. Okay, now it's full speed. Now it's full speed. Okay. I think I had a small interruption. I think it's full speed now, thankfully. Yeah, sounds good. Okay, somebody says, please teach ML. Again, please understand that the objective of these live sessions is to improve the programming skills and not specifically machine learning. So we will cover machine learning, and again, we'll cover machine learning from a programmatic standpoint later, right? So the objective here is not to teach machine learning. I think I've mentioned this earlier in the announcements also. Somebody says, can we apply recursion in class? You can. You have to be careful, but you can apply recursion in classes. Again, try it, right? It's very simple. Very importantly, somebody, again, let me go back to this question. Somebody is asking, please teach machine learning. I think we made it very clear at the very beginning when we announced these live sessions that the objective of these live sessions is to improve programming skills of the students, right? I think I taught a bit of numerical programming also, again, in the context of machine learning applications, without doubt, right? So I hope there is, yeah, now I'm streaming at like 6 Mbps now. I hope there should not be any hiccups now. Sounds good. Now let's go into some of the questions from yesterday's live chat window. Okay, somebody said, what is the use of empty classes? Okay, these are the questions. One by one, I'll tackle them. There are some concepts also that I'll introduce as we go. Okay, first and foremost, somebody said, what is the use of empty classes? I think I mentioned in yesterday's session itself, it can be used as a structure in C programming. Now, those of you who don't know structures in C programming, here is an example that I've made. Okay, so let's say I have class E. Okay, there is nothing, it's an empty class. So here, if you notice, what I've done here is, I've created a variable E1 of class type E. Again, remember, E is empty. Class E is an empty class. Let's not forget that. Class E is an empty class. Cool. Now I can create any variable name or attribute name that I want and give values to it. So I can say E1 equals to E. Okay, so this is an empty class. Class E does not have any attributes, does not have any methods. But because it is an empty class, I can use it as a structure in C programming language. Right? So one of the applications of structures is this. Suppose I create E1, a variable of class E. I can create any attribute name that I want. I can say E1.name is ABC, E1.number is 123, and if I print E1.name and E1.number, it will print ABC 123. Right? So I've created an object of E1. I've added whatever attributes that I want for this object. Because the class itself is empty, I can do this. If the class is not empty, I can't do it. Number one. Number two, I create another object of type E, of class E basically. Class E, I create an object E2. Now, here E1 has, look at this, E1 has name and number. These are the two attributes that I have. Object E1, not class E, object E1. Object E2, I can have the same attributes or I can have any other attribute. I can have name and address if I want, right? So an empty, one of the applications of empty classes is I can just use it like a box, right? You can think of this like this. E is a box in which I'm holding these two variables together. E2 is like a box or a container in which I'm storing these two values. Now, if I want to print these values, I can say E2.name, E2.address, E1.name, E1.number. I can do that. That's one application. The other application that I just discussed a while ago is if I want to inherit. So we have done this, we have written this code, right? If I want to inherit it from both classes A and B, but I don't want to implement anything here. Again, I have a bad habit of putting semicolons. It's not mandatory in Python, but since I come from C, C++ and Java world, I do put in these in place, right? So what do we do now? I just say class E, A, B. Now what does class E have? Everything that is there in A and B is inherited into E. I don't want to override anything here. I want all the stuff that is there in A and B to be inherited without overriding or without implementing anything extra. If I want to do that, an empty class like this with inherited, with base classes from which I'm inheriting is one application, right? So very simple. So next somebody asked, oh, this is a good question actually. Somebody asked, can we create a function within the init constructor? Again, for any question, the easiest way that I know of, again, it's always great if you can read documentation, but documentation can become very cumbersome. So whenever I get a question, I just write like simple code like this and see how it works. Okay, and then try to understand why it is working like that if I can understand, or else I'll read the documentation. So somebody asked in yesterday's live session, I think there was also a comment like this to which I responded today in the morning. Within the init function, look at this, in Python functions, you can define another function. So in the init function, because init is a special function, right? It's a constructor. Can we have another function within init? That's a question that somebody asked in the comment section, in the live session yesterday. So let's look at this. I have class A, def, this is my constructor. Within the constructor, I have another function. Look at this. This is a function definition. I'm defining a function called as function within, which is there within the init function. This is valid. You can define a function in another function in Python. Init is no special. You can do that even on an init. Because if you just write it, it works. Another very nice thing that somebody suggested, it's a very useful thing that I missed earlier, which is, there is this inbuilt function called dir. Okay. Very nice function actually. What dir does is this. Okay. Dir can help us obtain all the attributes and methods in a class, right? In a module or in dictionaries, in lists, etc. For example, Let's just write this, right? Import math. Remember, math is a module, right? I mean, you can think of math as a library or a module that you're importing, right? So print dir math. When I say dir math, what it prints is, it prints all the functions that I have in math. See, in math, if you recall, you have square root function that we have used earlier. You have a constant pi. You have math.nan that we have used in the initial live sessions. You can compute log base 2, right? You can compute cosine, right? These you can compute sine, right? You can get radians, all this stuff. So these are all the functions that are there in the math module that you can use. So at any point, if you're not sure, of course, one way is to go and read the documentation. The other way, if you don't want to go through the whole documentation, just print it if you want to know. That's the simplest way. Next, this can, again, the dir is a very useful. Here we are applying dir on a module. Now what happens if I apply dir on a class? So let's define a simple class here. Very simple example. Again, dir can be extremely useful to see what's happening internally. Okay, I wanted to cover, again, let's go to it. Okay, let's go step by step. Suppose if I say class B, within class B, I have function f that I have defined, and I'm saying print dir B. When I say dir B, all the functions and attributes that are there, especially the functions that are there in B, will be printed. Now, f is a user defined function. I've defined this function, the programmer defined it. So you'll see f here listed clearly. F is printed here. But along with f, there are many other functions because B is inheriting from the object class. Let's not forget that. Because there is no inheritance here, the default inheritance is from object. So all the functions that are there in the object are also printed here. Look at this. There is the default constructor that I told you yesterday about. There is str function that I told you yesterday about. There is also new function. I discussed about these three functions yesterday. New basically creates a variable. In it is the constructor. String basically helps you print the objects. I discussed these three yesterday, right? So dir is a very useful thing at any point for any class. If you're not sure what it should be, just go and say dir. You'll get all the functions that are there in that class very easily. Okay. So in this case, let's see. So if I want to know what is there in math, right? In math, so in IPython especially, if I type dot and if I type tab, so I just typed tab, okay? Those of you who can't hear, look at this, math dot, I don't know what is to be there. So if I just type tab, it will autofill. It will give me all these values. Again, this is very specific to IPython and Jupyter notebooks. So I can go here and I say, what is pi? Okay, there is pi here. Okay, and I can just execute it and it will print pi. Again, this is called as autofill or smart fill. There are much better integrated development environments that also tell you, given a function, it will tell you what are all the parameters in that function. So there are better and more complex IDEs for Python. The reason we use IPython is because it's much more widely used in the machine learning community to see how things are working step by step, right? So IPython or Jupyter is something that is very popular in the machine learning community, and that's why we are using here. But if you are using a different IDE for Python, it will have autofill, smart fill, smart suggest, all of those things. Okay, so somebody asked this question. Okay, so we talked about private attributes yesterday. The question here is, how do private methods work? Do they work very similar to private attributes? Yes, they work exactly like private attributes. Let's take an example. So I create a class C. Look at this. I create a class C. Again, please understand that I'm using Python. Okay, I should have said, okay, sorry, there is a small typo here, but that's okay. Not a major issue. So class C, right? So if you notice anything which has two underscores, again, this is a convention. These are all conventions. These are not rules of the programming language. When I say, again, rules are something, there are two differences. Anything that is a rule of the programming language, you have to follow it, otherwise it will go crazy. Conventions like these, like double underscore. If you have this is a convention that all the programmers agreed upon, but how it behaves depends on the implementation of the Python interpreter. Right? If you are again, we are using a Python interpreter to execute this code, right? It depends on the Python interpreter's implementation. So the convention says, again, when I say rule, it has to be strictly followed. Convention is something that everybody has worked on, but its behavior depends on the Python interpreter. Okay, they're two different things. So yesterday we saw that by convention, if you have two underscores, this will behave like a private member, right? Again, there could be some Python interpreters which will not throw an error. There are some Python interpreters that will throw an error. The one that I'm using now throws an error. What am I using now? I'm using the default one that I get in my, okay, where is it? Okay, I didn't run it. Okay, so let me just run it anyway. I think I'm using version 3 if I'm not wrong, but let me just check. Just give me a second. Insert cell above, import sys, print sys.version. I think I'm, oh sorry. So again, system basically is a module which has a bunch of interesting functionality. Yes. So I'm using 3.7.3 and I'm using the interpreter built in C, version number 10.0.1, all of that stuff. Cool. So in this, again, remember that having two underscores makes a member, whether it's an attribute or a method doesn't matter. Here, this is a method. Yesterday we saw private attributes. This is a private method. So now let's see what happens. So this private method is called within the class. Okay, so I have class C. Let me explain this code snippet quickly, right? So I have class C, which has a function which is underscore PR, which is a private method or a private function. And I have PU. Because there is no underscores before this, I treat it as public by convention. This is not a rule, it's a convention. That's a subtle difference that's important. So within PU, I'm calling this function. Okay, again, this should be okay, right? Because it's in the same class, a private member should be accessible within the other members of the same class. It's not accessible from outside. Okay, so now let's see. So I said C equals to this. Okay, I'm creating a variable called lowercase c of class C. I say c.pu4. Okay, I think there is a small error in the code, but let me just execute it. Yeah, so okay, the error was slightly off, but anyway. So now what happens? I created this, I execute this. Now what does it do? Again, remember that there are no underscores here, so it's a public method. So it will pass 4 here, x equals to 4. Now within this, I'm calling the private method. So what is it saying? Self dot. Again, from within this public function, I can call the private function. Nothing stops me from doing it, right? So I pass 2 power 4 is 16 plus 1, I return 17. 17 is being printed. No worries. Now, when I call this, remember the convention says if you have double underscore, it's a private. So if I try to call this private method from outside, right? Look at this. I'm trying to call this from outside the class. From within the class, there is no problem. When I call it from outside the class, what happens? Look at this. It says C object has no attribute underscore PR. So it says it has no object at all to start with. So now one thing that you can do here. So you've just run this, right? You can use DAR here to help you. So if you say print DAR C. Print DAR C. Yes, the syntax is right. Look at this. So print DAR C, what should it do? It will print all the functions that are there in this class C. Now if you notice, like all these, so look at this. You have your PU here. You have your PU here, the public function. You also have your PR, but PR is not as PR. PR is represented using this. Look at this. Again, the others are all being basically C. The class C is deriving from object. That's why you get all these other functions. But the PR function is not there as PR function. It is there as underscore C underscore PR. Again, this is a hack that Python does internally just to cover up its private variables or private class members. Again, this is something so this is often called as name mangling. So in the documentation that I shared yesterday also, so private instance members, right? Whether it's a variable or a function, doesn't matter. So what it does is it internally represents this using this concept called as name mangling, which again, that is for internal details. Again, if you want to learn that, you have to learn the internals of how Python stores all these things internally, right? So when you write DARC, you see the PU, which means it's a public function, so you should be able to call it. But the PR is not available. PR is represented like this, which means it's a private function which you cannot call. So given any class, if you want to know which are private and which are public, the simplest way is to print this. Anything that you see in the simple form like this, at the end, they're all public, this is private. Again, both private and public, the double underscore is a convention. Let's not forget that. The double underscore is a convention, right? Some interpreters respect this, some interpreters do not. The interpreter that I am using, which is the interpreter in C language version 10.0.1 or this whole thing, this is following this convention. It's not a rule, it's a convention. Okay, sounds good. Now, okay, next comes somebody asked a very good question yesterday again, right? So, okay, sorry. Okay, so there is no problem with speed, right? I just wanted to ensure that before I continue. Okay. Okay. Oh, somebody's asking, can we call? Okay, that's a good question. Can we call it using this? So let's try it. I don't think you can call it, but let's try it. Again, I'm not like deep internals expert, but let's try it. Why not? Insert cell below. Again, I think that will be slightly implementation dependent, but let's try it, right? C dot, so we have variable C, right? We have variable C. What did we call here? We called this. So instead of calling this, so what you're suggesting here is, let's call this with C underscore C. Is that what it is? Underscore C underscore PR4. Oh, it worked. Yes. So it worked. So somebody asked this question. It's a good question. So can we access the private variable from outside using this syntax? Again, that is implementation specific. At least the interpreter that I am using is letting me do that. Because again, remember, the whole concept of private methods is a convention. It is left to the interpreter and programmers to figure it out. So within again, if I call, again, this is a question that somebody asked, very good question. I just bumped into it, right? So again, in some interpreters, this might work. In some interpreters, it may not work. In this interpreter, it's working. Just wanted to make that clear, right? Again, any doubt you have, just write 5 lines of code and you'll be able to figure it out. That's what I do very often because I don't remember the internals of Python programming so well that I just try it. I just say, okay, I don't know. Let's figure it out in 5 minutes. What's that? It's not rocket science. Again, if I were a software engineer designing production quality C code, I should be knowing much more internal depth than this, obviously. But as a machine learning guy, because I'm not going to go into internals as much, it doesn't really matter. Okay. So yesterday somebody asked this question. I think they were a C programmer. So just like public and private, in C++ there is this concept called as protected. So again, public, private and protected are keywords in Python, in C++. So somebody asked, do we have protected members in Python? Okay. Again, remember that in Python, everything is public by default. It is only convention that if you put 2 underscores, it will make it private. And if you want protected, and I'll tell you what is protected with an example. Protected, 1 underscore makes it protected. Now let me show you what protected basically means. Okay, so the definition of protected in C++. In C++, the definition of protected is this. This variable, whether it's a function or whether it's an attribute, it is accessible in all subclasses, but not from outside the class. That's a definition in C++, right? That's a definition in C++. So let's modify the code that we wrote a while ago, and I'll explain you with examples, right? Cool. So now what do we have? Okay, so double underscore basically it is private due to 2 underscores. Again, it is implementation dependent and it is a convention suggested, right? So you have private and you have public. Cool. Both of them are cool. Now if you inherit it, look at this. So this is private, this is public, right? So this is where things get very interesting. I'll introduce you to protected with a small example. So I have C here. Let me use a different color. I have class C here and I have class D. There is, again, remember that private and protected are only implementation specific conventions, not part of Python programming. I can't re-emphasize this. In Python, by default, everything is public. It is just implementation. I can write a Python interpreter where I don't give a damn about double underscores or single underscores. So it's a convention that is used. Okay, so now come back, let's come back here. You have double underscore PR and you have PU. Right? Now let's go and, okay, so I have class D which inherits from class C. So within class D I have function F1, F2. Cool, all this is cool. Now let's do a couple of very interesting things. First I'll say print DAR C. I want to see what all stuff are there in C. In C, if you notice, we have seen this earlier, right? Your private function is there as underscore C underscore underscore PR. Your public function is there as public itself. Cool, that we have understood. What about D? So I create an object of type D and I say print dir D. Now in dir D, what do you have? This is interesting. In dir D, look at this. In D, look at this. In D, what all functions do I have? I've defined F1, F2. So I have F1, F2 because I've defined it in the definition of D. And D is also inheriting. Remember that D is inheriting from C, which means everything that is there in C will come here. So if you notice carefully, you get PU here. You get PU here, right? You get PR also here. So when I say dir D, I get this also, right? And if I say print D dot, again, one more interesting thing. Suppose if I have this, okay, so very interestingly, one more case, okay. So my D has whatever is there in my C is coming into my D. Along with it, I have two more functions F1, F2. Now here comes the interesting part. Now if I call print D dot F2 with 4 as the variable, now what happens? Let's see what happens. I pass my 4 here. I think I'll have to execute this. There is a small error somewhere in the code. Let me also execute this. Okay, fine, cool. I wrote 2 power I instead of 2 star star I earlier. I was doing some other notation in my head. My bad. Anyway, so the moment I call this, look, let's see what happens here. I go to F2. F2 is being executed with I equals to 4. Then what is F2 calling internally? It is calling PU. Now where is PU there? PU is there in class C, right? Remember, class C has PR and PU. From this, I have D. D has F1 and F2. I always draw diagrams like this so that it's easier for me, right? So I call D dot F2 4. Cool. D has F2. I go to F2 and now F2 internally calls PU. It can call PU, right? Because PU is a public function, right? So it can call, it will work. Perfectly, it will work, no issues. Now comes a funny part. Okay, now instead of that, now let's look at this. Imagine if I call D dot F1, and if I pass 4, what happens now? Okay, suppose if I say print, if I write this line, print D dot F1 4. If I have not written it, that's there in the next thing, but I want to show with the code. If I run this, what happens? First, D has F1, so I go to F1. There is one parameter, this parameter value will be 4. Now I am saying self dot underscore underscore PR. Look at this, I am saying underscore underscore PR. But then PR is a private member of C. PR is a private member of C. Now the question here is, again, in this implementation of the interpreter, can I access PR? What am I doing here if you think about it? From a subclass. D is a subclass. Let's not forget that. From a subclass. D is a subclass. C is a parent class. This is one of the terminologies also used in C++. C++ was one of the first object-oriented programming languages. So a lot of terminology came from there. So now what happens? Look at this. I'm calling a private function in the parent class from a subclass. This implementation gives an error. So this implementation says, if you have a private class in the parent class, you can only access it in this class. You can only access this function in this class. Any private member, whether it's an attribute or a method, you can't access it even in your subclasses. So when I execute, again, remember, this is all implementation specific, unfortunately. Okay, so a private variable, again in C++ also, a private variable or a private function, you cannot access it in subclasses, right? Cool, this is simple, right? Now let's see, when I execute this line, let's see what error I get. I know how to fix it also now. So if I say D.F14, it just say D object has no attribute underscore D underscore underscore PR. Now what does this mean? Look at this. What does it say? It says, I don't know D underscore underscore PR. I don't know how to run this. Look at this. It says, I don't know how to run this. I just can't run it. Because in D, when I inherited D from C, look at this. When I inherited D from C, the private function was not inherited. But here comes the interesting part. But if I want to call this, is there a way around? In this interpreter, in this implementation of the Python interpreter, there is a way around. Because the moment I said print DARD, what did I get? Where is the PR function? The PR function is called underscore CPR. This is what I have now. Right? So if I just change my implementation, instead of calling self.this, if I say self.c dot double underscore PR, because in my class D, when I say dir D, I have this, no? I have this. So if I do this, I'm assuming that in this implementation it should work. Let's try it. Okay, no error. So I'm calling F14. Now let's see if this works. Yes, it works. Look at how I've changed my code. Earlier, what did I have? Earlier, I just had, again, this is implementation specific. I'm repeating it multiple times. Earlier, what did I have? I just had self dot underscore underscore PRI. That did not work. Right? Because of the name mangling thing that Python is doing. But instead of calling it like that, if I just call it using this name, it was working. How do I know I have to call this name? Again, as somebody just asked a few minutes back, I just tried that a while ago. I tried this here, right? It was working. Because it is working in this implementation of Python, I said, when I do print DRD, I'm seeing this function here, which means I should be able to call that function. What stops me from calling that function? Nothing. So I just call that function, it's working. Right? Again, this is a confusing part. Whenever you're using a Python interpreter, you be very careful to check for all these cases because this is implementation specific. But name mangling is something that is done in, at least in the official interpreter that is given by python.org. This is how it's implemented because to the best of my knowledge, I'm using the official Python interpreter. Okay, sounds good. Now, okay, all this is good. Now, what if I want slightly different stuff? Okay, there is this concept called protected, right? The way protected works in C is, in C++ is this. So if I have a class C, if I have class D, again, we represent protected by convention using a single underscore, private by 2 underscores, public no underscore. That's the convention in Python, right? Suppose if I declare a function like this, let's say I say PR or protect, PR or let's call it protected, right? Let's call it protected here. Now if D inherits from C, right? So what is protected technically in C++? Protected is accessible in all subclasses. So in this subclass, I should be able to access protected, but I should not be able to access it outside the class. But here in this implementation, what happens here is, okay, let me show you the code so that it becomes clearer. In this implementation, I can access it. Okay, let's go through. So protected in Python is 1 underscore, public this underscore, this is 2 underscore. Remember, convention and not a feature of the programming language. It is implementation dependent. Again, you can read the documentation here. Now let's see. Okay, let's see slightly modified version of this. I have class C. Again, here single underscore. So it is protected by convention. Protected due to 1 underscore. Again, it is convention implementation dependent. I just always mention that. Then I have C. So what do I have now? Let's write down the structure here. I have C, which has underscore PR and PU. And I have D, which has F1 and F2. Now within F1, look at this. In F1, I'm using the protected method. And I should be able to use it. Right? I mean, it's a protected method, right? Technically, I should be able to use it. I have a public method. Public anyway I can use. But to be very clear, let's actually print the DARs. Again, DARs are useful. If I just say DARC, look at this. This is very interesting. If I say DARC and print it, look at what all I get. I get my PU, but I get my PR, my underscore PR. I don't get name mangling. Look at this. Name mangling is not happening. Name mangling is not happening. If you remember, if I put double underscore, if I made it a private variable, the name mangling was happening like this, right? Earlier. We saw this C _PR. This was what was happening for private, right? For protected, when it just do one underscore, nothing is happening. No name mangling is happening for protected. Because in this official implementation of Python, they actually don't care about protected. While if you want protected in the programming language, you can use the convention. Here this single underscore PR is just being treated like a public method. I'll show you how in this implementation. Again, I'm using the official CLang interpreter that is given by python.org, right? So the single underscore PR, look at this. So, okay, this where I run it, look at this. So when I run, okay, let's look at this code, right? df14, okay, so I'm calling f1, right? So I'm passing 4. This is calling underscore PR. No errors. It is giving me an answer. No errors. See, when I execute this, it gives me an answer comfortably. It gives me an answer of 16. No errors. But now here comes another question. Remember, this is single underscore. Earlier, for private methods, we could not call it from outside the class. Look at this. I have class C. In class C, by convention, this is protected and this is public, right? In Python, in this implementation of Python, in this interpreter, if I say C equals to C, I can call the protected method from outside the class. So the protected method, right? Protected method is just behaving like a public method in this Python, in Python 3.7 using the CLang interpreter. In C++, it behaves slightly differently. Those of you who know C++. So the way protected works in C++ is, it works like a private variable, which means you can't call it like this. This won't work in C++, but you can access it in subclasses, right? So the whole reason in having protected sometimes is those people, designers, those object-oriented designers who designed earlier in C++, who want to follow the same convention of public, protected, and private, they can just follow this convention and say double underscore basically means private, single underscore is public, and single underscore is protected, no underscore is public. But this is just a convention. The Python 3.7 CLang interpreter is respecting private. It is not respecting the protected definition as in C++. Right? Just wanted to make that clear. Another question that came up yesterday was constructor overloading. Again, this is somebody probably who wrote C or C++ code, sorry, not C code. So again, it doesn't work in Python. Let me show you an example. What is overloading? Suppose if I have class A, I'm defining two constructors. Look at this. This is one constructor. I'm again defining the same constructor. There is a difference. This constructor is only taking one variable. This constructor is taking two variables, which means this constructor is different from this constructor. Cool. So this is what is called as constructor overloading in C++. Right? Again, this is possible in C++. In Python, what happens is this. If I just say A1 equals to A10, look at this. I'm just passing one parameter. If this was C++, it would actually call this function and it would execute without any errors. Python says, sorry, I'm not doing any overloading. Whichever is the function that is defined later. So it says you have defined, see, it doesn't give an error here. For this snippet of code, it doesn't give an error. It gives an error here. It gives an error for this line. So what Python says is, okay, you have an init function. You are doing one more same function with a different set of parameters. So whatever is defined later, I will take this. I will simply ignore this. So now if you pass only one parameter, this will say, hey, I don't have anything which is one parameter, so it will throw an error. So what it throws is this. Look at this. It says, again, where is the error? Error is in this line. It says, init missing one positional argument j. So what it's saying here is the init that I know is this. Because again, remember, this is there and this is there. So whatever is the later definition, it keeps that. The earlier definition, it will completely remove. It will get rid of it. Right? Again, this is one form of constructor overloading. This is one form of it. Right? So now in this case, it will only take the later definition and it will make it work. Cool. So that was one of the questions. Another question. Oh, so on the other hand, if I don't use this one parameter, if I just give two parameters, If I just give 2 parameters, there is no problem, right? It will take, because this is the valid one or this is the active one. This got overwritten here. This got overwritten, only this exists, you don't have this. In other programming languages, this will work without an error. This will also work in an error, but not in Python. Now, another question. Can we call other functions within init? Okay, this was a question that was asked. Okay, look at this. Can we call another function within init? Why should we not be able to call it? Okay, let's see, but let's be sure. Let's just write simple snippet of code. So my init has 2 parameters ij. I'm calling another function called f. Cool, there should be no problem here. Right? I'm calling this function f. Cool. I mean, what is the problem here? Everything should work, right? But the moment I execute this, I start seeing an error. I say, okay, suppose I go through this, I read name f is not defined. Why the heck name f is not defined? I have defined my function here, right? What is wrong with Python? Why is it misbehaving? Look at this. Very simple code here. Very simple code here. Right? Again, look at this. In the constructor, I'm calling in another function in the same class. Nothing crazy. Same class, I'm calling in another function. This should work, right? The problem here, again, a very common mistake is not using self. You should say self dot, then it will work. Look at this. Again, it's a very common mistake that people do, is missing out self when you're writing your own classes. Please don't miss out self. Self is extremely important, because here it didn't understand what f is. The moment you change it and say self.f, which means in this object, there is a function called f, call that function. The moment you do this, everything will work, right? That's it. That's the only error. Now, again, so I think, yeah, we have 10 more minutes. So these are some of the questions that I saw from yesterday's session, which I thought we'll cover. Again, anyway, I was planning to cover protected methods today, but thankfully somebody asked that question and we got it away. Again, the most important thing is, again, if you have worked for years on Python and if you have worked as a software development engineer, you are expected to know the internals fairly well, right? If you have especially worked as a software development engineer for a few years. For machine learning folks, the internals of object-oriented programming, object-oriented design, if you know some internals, it will help you. But at any point, if you're not sure of the internals, this is what I do. I do not consider myself as a very good Python programmer, because I've seen people who know the internals like crazy inside out in my own team, phenomenal senior software engineers. I don't consider myself to be an expert at Python internals. I know a few of them, not all of them. And if I don't revise, I forget. Very common, right? And as a machine learning guy, I mostly use a lot of others libraries and things like that. So I seldom implement classes and objects of my own unless I have to extend an existing class so as to help my software engineers build it, right? So the amount of object-oriented programming that I have written is less than 10% of my total programs that I've ever written, all the in almost 10 plus years, right? As a machine learning engineer, machine learning scientist, all of that, right? I think I've written less than 10% of my code, probably even less than 5% of my code, okay, in object-oriented, using object, like I have used object-oriented programming because I use classes, I use objects, I use all of that, but I have not written core object-oriented programming with multiple inheritance, wherein I have to know all the internals, etc. For a software development engineer, they spend almost 70+% of their time writing classes, doing object-oriented design. Hence, they know the internals much better, right? So everybody has their skill set. So at any point, my general suggestion is this. If you don't know how the internals work, simple. Just write a simple snippet of code, figure it out. If you're not sure, just read up about it and write a snippet of code, right? So just one more point. In later sections, we'll use major libraries. Again, in later sections, both if you're a course participant, in the course we use lots of libraries. Also in the future live sessions that we are planning to conduct in this series, we'll use a lot of major libraries, either for plotting like matplotlib, scikit-learn, the tons of libraries we use. Again, in those instances, we will revisit some of these object-oriented programming concepts, because in there, I can actually show you the practical aspects in a lot more depth. Right now, I can't take you to scikit-learn and override, let's say, logistic regression, because you don't know what scikit-learn does. you don't know what logistic regression does. At least I did not expect that to be a prerequisite for this session, right? That's why I'm not covering it, but as we progress in this series, I'll surely cover more we'll revisit again and again the object-oriented concepts when we look at other machine learning, data science, and plotting libraries, number one. Number two, as an exercise, what we'll do later is, we will extend some inbuilt classes. Like I told you, right? In scikit-learn, there is this class called logistic regression, right? So we will extend somebody asked this question in yesterday's live session, but I thought it is not right to implement here because there are participants here who may not know how scikit-learn's logistic regression works internally, right? What even logistic regression does or what scikit-learn does, because I did not mention that as a prerequisite. So later on, as we progress in this series, I will extend the logistic regression specific, I'll extend some of these logistic regression, I'll extend the logistic regression class, and we'll modify some of these classes to suit our needs. But that we'll do later after we cover a bunch of libraries for machine learning, data science, plotting, statistics, deep learning, etc. We'll do it in a very contextual manner so that you're connecting the concepts to real world stuff instead of just learning it. Again, remember, all this that I explained here, if you don't connect it to practical stuff, we'll forget it in no time. I've forgotten some of this, to be honest with you. I've not used multiple inheritance. I don't recall diamond inheritance. I know what it is. I've never used it, so I don't know how Python behaves in that situation. Right? It's very common to forget it. So it's okay. Just revise these concepts as and when you need. Better still, whenever I am in doubt, I just write code. Right? So that's my suggestion here. Somebody says, can you tell about operator overloading? We'll do that later because operator overloading is a slightly different concept. We'll probably do it at a later time, right? Sounds good. So any general questions? We have like 10 more minutes. So any general questions you have, I would happily take some of these. And again, we'll announce the next bunch of live sessions on YouTube little later. We are just still planning what we should cover after this. Oh, good. Somebody says, very good. Vamsi, you say, I feel like cheating when using a method or class directly without actually knowing the know-how of it. Example, NumPy or any other particular research, what is there? So the problem here is this, Vamsi. To be honest with you, it's very hard to know everything. Because my question to you is this, okay? Suppose we are using ND array, okay, to represent an n-dimensional array in NumPy. And we have used it in the previous live sessions. You can go one step below, right? You can go one step deeper and say, hey, I want to understand how ND array is implemented. I touched upon it in the previous live session, right? It is implemented just as a block of memory and this is all implemented in C++, right? This is basically a block of memory that is used. Now you can go one level deeper. You can say, hey, how is this block of memory? How does C program allocates this block of memory? Okay, then you have to know concepts in operating systems called virtual memory, right? Then you have to go into the core of operating system kernel itself. Then you have to go into the hardware itself. So where do you stop? Again, an undergraduate computer science student learns many of these things. Again, you learn about virtual memory and operating systems in operating systems course. You learn about hardware in computer organization and architecture, right? Again, the high level details, to be honest with you, I know the high level details. But if you ask me specifics, like, okay, how does, again, when you allocate a block of memory in C++ using malloc, right? What functions does malloc internally call? Imagine if I'm using, let's say, a Linux operating system. Within the Linux operating system, what functions exactly is malloc calling? Or if I'm using the Macintosh, the Mac OS, what functions is it exactly calling? How does the C compiler work internally? Again, there is this whole thing of compiler design that will also come in here. Right? So there are a lot of designs. My question here is, where do you stop? At an undergraduate level in computer science, you're given a broad overview of many of these concepts. Right? Imagine if I'm developing a compiler for Python, right? Or if I'm developing a compiler for C++, then I have to read the whole compiler design textbook, the famous Dragon book, right? And explain these concepts in depth. And I have to know many more things if I'm designing the compiler, because if I'm designing a compiler for Linux, for C++ on Linux, I have to know a lot of Linux internal functionality. How does linkers work? How do loaders work? There is a ton of thing. Again, I know some of these things because I've refreshed it recently. I've also taught GATE computer science, where I taught all the undergraduate core subjects, right? But if you have not worked in a field, it's very common to forget it. So in machine learning, knowing these things is good, but knowing these things will not help you solve the problem at hand. Suppose if your problem is, okay, I want to predict what the sales of the company next year is, right? You want to build a time series forecasting problem. Knowing these things is great if you know it. But then your problem is not knowing these things. Your problem is to use existing functionality and to solve the problem at hand. That's what a machine learning engineer, that's what is expected out of it. But if you have studied undergraduate computer science, you will have some high level knowledge of all of them, if not in-depth knowledge. You can only gain in-depth knowledge by actually implementing it. If you have implemented a compiler of your own, you will learn it. If you have built an operating system of your own, you know it. If you have designed a computer architecture, if you have built actual, like if you have worked on 8085, 8086, Pentium, the other processors or ARM processors, only then you understand the core hardware. Nobody can be an expert in everything. So it's okay to use existing functionality, right? Okay, so again, I'm just scrolling. Yeah, somebody's asking, do you plan to cover PySpark in future sessions? We want to cover PySpark, but in the context of machine learning only, right? So because PySpark itself is like a massive thing, like teaching somebody whole of distributed. Again, what our teaching philosophy at Applied AI course has always been, when we teach something, we want to go into the internals as much as possible and do it. And the objective, again, we have done a session called how to use Spark for machine learning applications, right? We have done a live session on this. We were thinking that in the future sessions, we will focus on using Spark, again, using Spark for the core tasks that you have in machine learning. For example, can you build a data pipeline? How do you build a data pipeline in Spark, right? Of course, remember, I'm assuming that you know SQL. So there is something called a Spark SQL. So we will build it in the most popular way, which is Spark SQL. Instead of writing code in PySpark, it is much more easy to build data pipelines in Spark SQL. So we will do that, right? Next, if you want to do, let's assume you want to build some machine learning models in a distributed fashion. Now I can implement these machine learning models in raw PySpark, but why do it? There are already beautiful libraries like Spark MLlib, which we can use, right? So we want to cover Spark from an applicative perspective on applications that are most relevant in the context of machine learning, because PySpark is much broader. If I have to teach PySpark or even Spark to its core, I think for software engineering or distributed systems applications, again, for machine learning applications, it's very simple because people already know how machine learning models work. They've seen a bunch of libraries like TensorFlow, scikit-learn, and XGBoost. They've seen a bunch of libraries, right? They know how the mathematics internally works. So now we're just simply using MLlib with some, of course, there are some Spark specific things that they have to know, but they don't have to be experts at PySpark, right? They don't have to know the internals of how Spark distributed computing actually works. They don't have to know how RDDs work internally in Spark. So again, most machine learning folks use Spark mostly for building data pipelines, for building machine learning models, and for some data analysis. So we will cover Spark from this perspective, not from a software development engineer or not from a distributed systems engineer perspective, right? Because that's a whole course onto itself. This we can't cover in 2 or 3 live sessions. This we can cover in a few live sessions. Okay, sounds good. So if you write a class, then how other people are able to use that class? So you should just check yesterday's live session. So in yesterday's live session, we did this, right? We took, again, we just took a library. So I gave this example yesterday, which is, I built a URL shortener called short URL final, right? Let's assume this is there in a library, right? If somebody wants to change the functionality of it partially, then in yesterday's session, I created my URL shortener, right? As a derived class from this base class. So this was my base class. This was my derived class. I wanted to use most of the functionality of this class, but change a couple of things. Whatever I wanted to change, I just used inheritance. I got all the functionality here. I changed whatever functionality I wanted. That's how you extend or you inherit a class and modify it to your needs. So somebody says, do you recommend any certification for Python specifically for data science and machine learning? I don't know any, to be honest with you. Again, certifications which are proctored by which I mean, anyway. So again, in the industry, certificates, especially at top product-based companies, certificates don't matter much, to be honest with you. But there are some certifications which are proctored, which means there is an invigilator, right? So there is an invigilator and you have to go to a test center and write a test. These are given more preference. So you have to go to a test center so that there is no cheating, right? So there is no cheating. The test is conducted in a proper manner. So those tests tend to have higher weightage in the industry, number one. Number two, the test also has to have a high bar. It should have a high bar. If the test is like trivial test, then the certificate is useless, right? See, in the real world, recruiters say, given a certificate, can I trust that certificate, which can only be trusted today? Most of the cases where it's trusted is where there is a proctored or an invigilated exam in a physical location. So recruiters respect that, or companies respect that. And the bar has to be high. There are some certifications which are, actually most certifications don't have a high bar, and most certifications are not proctored or invigilated in a test center. That's why most product-based companies don't care. There are, again, for distributed systems and cloud computing, there are some certificates that I know of. There are some certificates by AWS and by Azure where you have to go to a test center and you have to write those tests. And these certifications are somewhat respected by the industry. But again, the bar for them is okay, not too good. The bar for, again, I've seen some of these tests, even for machine learning, the bar was okay. It cannot measure if you're a really good, again, it doesn't give you that scale that this guy is a brilliant machine learning engineer, this guy is an average guy, etc. Because both the average guys and the brilliant guys get roughly the same marks, right? So some of these certificates, again, if you are applying for a machine learning role in some of these top product-based companies, I don't think any of the certificates that I know of, again, my knowledge is limited here, any of the certificates are really that useful for Python or for anything. So are NPTEL certificates worthy? Again, I've never seen any company taking NPTEL certificate seriously because, again, they have the same problem, right? Is the exam high bar? Is the exam being conducted in a proctored or invigilated manner? If it's not, nobody cares, to be honest with you. Again, I've done quite a lot of interviews and I've seen people send me all sorts of certificates from a bunch of MOOCs. And I don't think the recruiter ever used those MOOC certificates as a criteria to conduct an interview. I don't think so, to the best of my knowledge. So if getting a call for Python, not ML, so is it good for that? So you're saying the certifications, again, what certification are you talking about? Any certification that you take, just make sure in the real world, guys, let's get real, right? It is exams with high bar. Any exam in the world where the bar is high, where the exams are proctored. Proctored basically means there is an invigilator, right? And there is very low scope for cheating. Only when these two conditions are satisfied that the certificate has a value. It could even be your degree certificate, right? Suppose you have a degree certificate or a bachelor's degree certificate from, let's say, IIT Bombay, or you have a master's degree certificate from IISc. People know that the examinations at IITs and IISc are quite hard. They're not trivial by any means. And all the examinations are proctored. So somebody who has gotten a 9 out of 10 CGPA or 9.5 out of 10 CGPA, or in the case of IISc, the CGPAs are all out of 8. Somebody who got 7.2 out of 8 CGPA, those guys have cleared a very high bar and the exams are proctored and invigilated. That's why these certificates have a high bar. On the other hand, take some university, take a tier 3 university. Take a tier 3, I don't want to name any universities, take a tier 3 university. Yes, I'm happy that the exams are proctored, right? I'm assuming that very little cheating is happening. Again, most universities in India are truthful to this matter. But the examination bar is too low. They'll just ask you some theory questions. Like I have studied in a small university. I may not be able to call it tier 3, but it's a small university, in a small engineering college. In the examination for recursion, I would be asked to write recursion for Fibonacci. That's a joke, guys. That's a textbook example. At IIT, you'll be given a real hard problem and you'll be told, okay, write the recursive function for this, do the time complexity analysis, do the space complexity analysis. We were asked, write the program for Fibonacci. So the examination is low bar. That's why universities, even though they give degrees which are proctored, the degrees don't have high value. That's the problem. This is true across the world, not just in India. If somebody graduates from Stanford, right? Stanford exams are really high quality. Their coursework, you have to do real world projects to get through. And all of them are very well proctored. Their process is terrific. If you are found cheating on any of your assignments, they'll simply throw you out of the university. First time they'll give you a warning, second time they'll throw you out of the university. Right? So they have a very high bar of exams and they're proctored. That's why there is value in the certificate. This is true for any certificate, whether it's given by a university, a company, anybody. Even in our applied AI course, we try to maintain the high bar through our assignments, right? We try to maintain it using assignments, and we don't have real-time proctoring, but we check for each of our assignments. If there is any plagiarism, we just don't give a certificate. This is one of the ways that we figured out. Again, we're also experimenting, right? So we also have this platform called MasteryGo, which we built, right? So in MasteryGo, we can conduct tests. Again, this is still an experimental platform that we're working on, wherein we'll give high quality tests and we will proctor them using your webcam. We'll do screen recording, we'll do webcam recording, and we have actual humans and deep learning systems that will actually evaluate to see if there is any cheating. If there is even a suspicion of cheating, we do not give a certificate. Again, I think online methods are also slowly evolving to create high quality proctoring, because giving a high bar test is easy. Right? It's the same test, whether you take it offline or online is easy. But online proctoring and invigilation is, I think, the future. Because then more and more people can get high quality certificates. Low quality certificates are useless. Right? So I hope you understand that. Sounds good. Okay, folks, thank you very much for joining in. We'll again, please just follow us on YouTube if you want to know about future live sessions. Again, we'll make these announcements slowly as and when we have the next set of topics that are ready. Okay, thank you very much. Bye-bye.